I'm going to show you how we can use arithmetic series and also how it differs from a geometric series. Okay, and in this video I'm going to mainly focus on developing the formula for arithmetic series and geometric series. Obviously in the following videos we're going to use these formulas and apply them to a lot of different questions, but I always feel like the most interesting part of the topic, as well as the most insightful part, is at the very beginning, just understanding where these formulas came from. Okay, so just to start us off, I'm just going to write two sequences so that we can see the difference between the two. So for example, I have this 1, 2, 3, 4, 5, 6. I have another sequence 1, 2, 4, 8, 16, 32. Right, so here we have two sequences of numbers. If you look carefully on the top sequence, it's just going up by 1, right? We just keep adding 1 to it. As opposed to the series on the bottom, or the sequence on the bottom, it's not going up by the same number, right? We're not adding a particular number. In this case, we're actually multiplying to get to the next number, right? So like we can see from here to here, we're just plus 1, and from here to the next one, we just keep adding 1, whereas in this one, we're multiplying a certain number, right? So this is what we call an arithmetic series, right? So arithmetic, and this is what is called a geometric series. Okay, so hopefully the names are kind of more intuitive to the different types of sequences that we're going to be facing. So in this video, I'm just going to focus on the formulas to find the sum of an arithmetic series. So I'm just going to get rid of this geometric one, which we'll come back to later on. And the way I always start off introducing arithmetic series is to just think about a very basic problem. So for example, 1 plus 2 plus 3 plus 4, say 100. So if we have a series like this, by the way, I feel like it's important for me to point out, when we say sequence, a sequence is a sequence of numbers, and a series is when you're adding all the numbers together. Okay, so when we have a series like this, 1 all the way through to 100, how would you go about adding them together? Now, obviously, you can try to use your calculator and just brute force your way through by adding all of these numbers. Not very sustainable, not very scalable, right? We can't really apply that method to a different problem, especially if the problem gets a bit more bigger. So how would you go about this? So in maths, we want to try to find patterns, right? So that we can apply the same pattern. If I see another arithmetic series, then I can just apply that pattern on. Okay, so what I mean is, one way we can go about adding these numbers is you can think about, let's say, if I just get rid of this 100 for a second, and I write 98 plus 99 plus 100. Right, so those are the last three numbers of this series. And if we think about, say, adding 1 to 100, that's just 101. And then if you think about, if I add 2 to 99, that's also another 101. And so in an arithmetic series, if you just add the last pairs of numbers together, then we keep getting the same sum. And that's what happens in an arithmetic series. Right, so the question is, how many of these pairs do we have? And what do you guys think? If you just have to think about it, like, where would it go if you just continue adding the pairs? Somewhere in the middle, you'll get say like 50 and 51, right? And then you would add those together to get the 101. So the answer to the question of how many pairs there are is there's 50 pairs, right? Between the numbers 100 and 1, there's 50 pairs. So we can say, the sum is 101 times 50 pairs. Okay, so whatever this value turns out to be. So using this pattern, right, we could apply this to any other arithmetic series. As long as it's an arithmetic series, you will have, let's draw up another one. Like, let's say say we have like, let's start from say 11 plus 13 plus 15 plus, and we go up to say, I don't know, 97, right? Or let's say 99. So this is another arithmetic series, and let's see if the same pattern, if the logic makes sense, right? So if I add the last two numbers, or say the first and the last number rather, that pair, 99 plus 11 is 110, and 13 plus 97 is also 110. So yeah, in an arithmetic series, if you add the first and the last numbers together and continue that pair through to the middle, you'll keep getting the same sum. And so we just need to find out how many numbers there are, divide that number by 2 to get the number of pairs, and then we should be able to get the sum, right? So we're just going to use this basic knowledge to actually create some sort of formula, okay? So this is what we're going to do. Instead of writing it in specific numbers, like specific examples like the ones I showed you, I'm going to write it very generically. Okay, so what do I mean by that? The first term could be anything, right? It could be any, depending on the question or the situation that you're facing, the first term could be anything. So I'm just going to call it A. Okay, and let's say in an arithmetic series, to get to the next number, we're adding a certain difference, right? So say the next number would be A plus D, right? So in this case, in our previous questions, so it looks like A is 1 and A is 11 in these two situations. If you look at the difference from here to here is 1, and these are all 1s, right? Whereas the difference here, it goes up in 2s. So whatever that difference turns out to be, we'll just call it D, and we'll say the next number is A plus D, which means the next number after that should be A plus 2 differences, right? And then we'll just continue this on. So if I add these series together, what would it look like to add the last number? Now again, we don't have any specific numerical values. These are all just pronumerals, right? So let's try to think about the pronumeral version of what this last number would be. Okay, so if we think about it, whatever the first number is, if you're looking for the second number, we're just adding one difference on, right? So let's say like when n equals to 1, so n being the numbers, like the rank of the number, I guess. So the first number is A. The second number is A plus D. The third number is A plus 2D. And so basically, if we have n being n, so whether n is 100 or if it's 50, what would this look like? It would be A plus n minus 1 lots of differences. Okay, so hopefully this makes sense. So for example, like for example in here, if n equals to 3 and you sub 3 into here, then we would get 2D. Okay, and so that's how these things match up. Okay, so another way we could write this as well, just to get into the habit of using some notations, this would be your T1, so that's your first term, this is your T2, this is your T3, and this would be your last term, Tn. And this is actually the first formula that we have, which is this Tn guy. Right, so if you have an arithmetic series, yeah, let's write it over here. So if I have Tn, this is our first formula. Okay, so you can highlight that one. So basically what this is saying is, depending on n, which number are you interested in? So if you're interested in the third number, you would sub n is 3, and you would sub 3 into here, and sub in the different values depending on the arithmetic series that we have. Okay, so this is the first formula to find the term, right? The fifth term, the sixth term, the nth term. So this is going to come in really handy. The other formula that we are interested in is the sum formula. So if we had to add all these numbers together, what would it actually be? So again, we're just going to bring the logic of what we did up here. And we're going to add the first number to the last number and concentrically go into pairs to the middle. Okay, so I'm actually going to say, yeah, let's bring this down a bit. Okay, because I want to use the same strategy as we did before. So A to this. Let's make it a bit taller. So first plus last is going to be 2A plus n minus 1D. Okay, so I added A and I added this. Right, now you guys can go ahead and check yourselves if you like, but if you have the second and the second last term adding and you continue that, they will all be the same 2A plus n minus 1D value. Just like up here, we kept getting the same sum for the pairs, right? So if they are an arithmetic series, then this pattern will always occur, right? The first number plus the last number times how many pairs there are, right? So if you had to continue doing this, how many pairs were there? Well, that's pretty simple actually. And basically, again, just going up to this example, the very first one we looked at, n in this case was, so how many numbers were there? Between 1 to 100, going up by ones, there's obviously 100 terms, right? So in this case, n was 100. And we said, okay, well, if n is 100, then that means there's 50 pairs. So that's why we multiplied by 50, right? So going back to our formulas here, so whatever n is. Now n, we don't know what n is. N is just n, right? Depends on the question. So the sum must be uh, 2a plus n minus 1d times n over 2, right? So that's the number of pairs that we have. And these two are it. So we have these two formulas. So I'm actually going to write that one down over here just to make it look nice. So for sum, I'm going to use S. Well, let's use a black one. So Sn is equal to, let's write n over 2 at the beginning, 2a Cool. And so these are the two formulas that we're going to need for arithmetic series. Okay, the term formula, the sum formula, and that's basically it. But there is actually just one last formula. You see basically what we did here. We did the first plus the last, and we found that sum multiplied by n on 2, right? The pair. So this last term, sometimes you know what the last term is, so we can say like, you know what, I'm just going to say or Sn is equal to n over 2 a plus l, right? So that's basically what we did. The first plus the last, and multiply that by how many pairs of numbers there are. Okay, so just depending on the question, right? Sometimes you'll have a situation where they tell you what the last term is. In that case, you would just go ahead and, because you know what L is, you would just use that. Sometimes you don't know what the last term is, but rather they tell you more information about the difference. In that case, then you would go ahead and try to use this formula, right? But I want to emphasize that these two formulas are basically the same thing, right? So this term n, the last term, if you sub this value into this L, then that's how you get this formula. Okay, so hopefully that made sense, and we're going to use these two formulas in the following exercises. Alright, sweet. I'll catch you guys in the next one.